Normandy, June 1944. The Tiger I is the most feared tank in the world. 88mm gun, 100mm frontal armor. It can destroy 5 Shermans before taking a hit. The engineers obsessed over every detail, especially the wheels. 9 overlapping road wheels per side that distribute 68 tons so efficiently, the Tiger has lower ground pressure than lighter tanks. Brilliant engineering. It's also why 20% of Tigers in Normandy spent their mornings stuck, crews chipping frozen mud out of wheels with crowbars instead of fighting. This is how perfect engineering became a fatal weakness. Let me show you what German engineers actually built. The Schachtelaufwerk interleaved running gear uses 9 road wheels per side, arranged in 3 overlapping rows. Each wheel overlaps its neighbors by roughly 40%. The pattern creates maximum contact with the track, spreading the tank's massive weight across more surface area. The math is impressive. A 68-ton Tiger generates only 14.8 pounds per square inch of ground pressure. For comparison, a human footstep generates about 16 pounds per square inch. This meant the Tiger could cross soft ground that would swallow simpler designs. The system also gave the crew an incredibly smooth ride. The overlapping wheels absorbed shock better than conventional suspensions. Gun accuracy on the move improved. Crew fatigue decreased on long marches. German tankers called it the best suspension system in the world. Until they got to Normandy, the bocage trap. The bocage changed everything. Normandy's countryside is divided by hedgerows, dense walls of earth and vegetation built up over centuries. Fields are small, rarely more than a few acres. Roads are narrow and sunken, carved deep into the landscape by centuries of use. The ground looks firm on top but is saturated clay underneath, and the rain that June was relentless. The problem wasn't the weight, the problem was the gaps. Those overlapping wheels created narrow channels between their edges, spaces about 3 inches wide where wheels nearly touched but didn't quite. Perfect for trapping debris. Normandy mud mixed with hedge clippings, stones, and plant matter. It wedged into those gaps. Then overnight temperatures dropped just enough to turn wet clay into something with the consistency of concrete. Every morning, Tiger crews faced the same ritual, chipping frozen mud out of the wheels before they could move. This wasn't a minor inconvenience, it was a tactical disaster. The morning paralysis. German field reports from Normandy consistently mentioned morning maintenance delays. Crews spending 2 to 3 hours clearing wheels before tanks could advance. In combat operations where timing meant everything, Tigers were immobilized not by enemy action, but by physics and French clay. Imagine commanding a Tiger in the bocage. Your tank is mechanically superior to anything the Allies can field. Your armor can shrug off most enemy fire. Your 88mm gun can destroy enemy tanks at ranges they can't even return fire from. But you can't move until noon because your crew is outside with picks and hammers, chipping frozen mud from between your wheels, while Allied reconnaissance watches from the hedgerows. And when something actually broke, the nightmare got worse. The repair catastrophe. Here's what happens when you damage an inner road wheel on a Tiger. You have to remove the outer wheels first. Military history now documented the process. Mechanics had to remove as many as 9 wheels from the outer course, undoing 54 bolts in the process just to access a damaged inner wheel. The entire repair could take 8 to 12 hours, and that's assuming you had the parts, the tools, and the time. In Normandy, German armor rarely had all 3. Compare that to a Sherman. The M4 used a vertical volute, spring suspension, 5 independent road wheels per side, no overlap. When a Sherman threw a wheel, the crew could replace it in 30 minutes with basic tools. This wasn't about American engineering being superior, it was about American engineering being practical. The Sherman was designed to be maintained by conscripts with minimal training under combat conditions. The Tiger was designed to be maintained by skilled mechanics in rear area workshops. Normandy offered neither skilled mechanics nor rear area workshops. The numbers don't lie. This difference compounded over weeks of combat. Wikipedia's Tigery article notes that reliability averaged around 70% from May 1944 to March 1945. But as World War Photos points out, this availability was only possible with extensive maintenance and proper logistics. And in Normandy, none of these conditions were met. The numbers tell the story. In the broader Normandy campaign, German armor faced catastrophic mechanical failure rates. History Tools reports that approximately 36% of Panther tanks were unavailable due to mechanical issues in Normandy 1944, compared to just 18% for American Shermans. The Tiger's situation was similar. The interleaved wheels that should have been an advantage became a liability in terrain they were never tested against. Allied adaptation, and the Allies noticed. They didn't need to destroy Tigers in direct combat. They just needed to outmaneuver them, force them into mud, and wait for the bocage to do the work. Allied tank crews learned to target Tigers during morning hours when German armor was stationary for maintenance. They learned that flanking attacks worked better than frontal assaults, not just because of armor angles, but because Tigers couldn't maneuver quickly in the confined bocage terrain. The hedgerows themselves became weapons. Tigers were too wide for many Norman roads. They couldn't reverse quickly in the sunken lanes. And every time they pushed through a hedgerow, more debris packed into those fatal gaps between the wheels. The logistics collapse. The worst part? Germany couldn't afford these losses. The national interest notes that damaged Tigers often had to be abandoned because the only vehicle that could tow a damaged Tiger was another Tiger. When fuel shortages hit in August 1944, operational Tigers were blown up by their own crews rather than let them fall into Allied hands. The Vimoutier Tiger is a perfect example. This Tiger I ran out of fuel near Vimoutier in August 1944 and was abandoned. It's one of around 60 German tanks left behind in the rolling hills near the single town as German forces retreated. Not destroyed by enemy fire, just abandoned. Because sophisticated engineering requires sophisticated logistics, and by August 1944, Germany had neither. Think about that. One of history's most fearsome tanks, mechanically intact, left beside a French road because there was no fuel to move it and no way to recover it. The lesson learned. The lesson wasn't lost on post-war tank designers. Wikipedia's Tiger II article reveals that even Germany recognized the problem. The Tiger II, designed later in the war, simplified the wheel arrangement to overlapping without being interleaved, trying to keep some benefits while reducing the maintenance nightmare. But by then, it was too late. After the war, every major tank design rejected interleaved wheels entirely. The Soviet T-54, 5 road wheels per side, no overlap. The American M48 Patton, 6 wheels, simple torsion bar suspension. The British Centurion, 6 wheels, external tracks, modular design. Not because the engineering was wrong, because the engineering was too perfect for the chaos of actual warfare. The final verdict. Part yard defense sums it up perfectly. The interleaved wheels were a nightmare if mud and ice got into them, and repairs to other wheels could take quite a while. That understated British phrasing hides a brutal truth. The Tiger's greatest strength, its sophisticated suspension, became its fatal weakness the moment it left the testing grounds and entered real combat conditions. The Tiger tank wasn't defeated by superior Allied armor. It wasn't defeated by brave soldiers or brilliant tactics. It was defeated by mud, clay, and the simple reality that complexity is the enemy of reliability. German engineers built a masterpiece, but they built it for a war that existed on paper, not in the hedgerows of Normandy. The next time someone tells you to optimize for perfection, remember 68 tons of German engineering stuck in Norman mud because 9 overlapping wheels worked beautifully on paper and catastrophically in reality. If this deep dive into engineering trade-offs hooked you, smash that like button and subscribe for more stories where brilliant design meets brutal reality. Drop a comment. What modern tech do you think is over-engineered for its actual real-world use? Thanks for watching. See you in the next one.